Next, we're going to be talking about domain of absolute value functions. And this one's going to take no time at all. Remember that an absolute value function has the bars to the left and right of the x. So what exactly, and again, if you graph it, it kind of looks like a V, like that, like a V-neck t-shirt. Think about this. For an absolute value function, whenever you plug a number into it, it just becomes positive, okay? No matter what you plug in, even if you plug in 0, it stays 0, but otherwise, even if you plug in a positive number, it's positive. Therefore, it's pretty easy to see that you can plug in anything into an absolute value function and you're going to get something back. For example, if you plugged in negative 10 here, you get 10 back, and so on and so forth. Let's take a look at some examples. So any of these functions, f of x equals 5 absolute value of x, if you plug something in, like if you plugged in negative 10 here, you get absolute value of 11. It's going to be 11, right? Or if you plugged in, say in this function, you plugged in negative 7, it's going to be squared and added 2. It's still going to be made positive. So it doesn't matter. It's always going to be all real numbers for an absolute value function. The domain will always be all real numbers. And that's true for absolute value functions as long as there's no modification. Like we talked about odd roots, there's limitations to that. If you were to combine those two, you'd have to take that into account. If it's just an absolute value and some variables inside, domain is all real numbers. If you have any questions about domain of absolute value functions, let me know.